Guess the word. Yes, you're right. Motion. In this lesson, you should be able to have 75% level of competency in the following desirable learning objectives. 1. Define the basic keywords and key concepts related to motion. 2. Formulate the equations of motion using the basic key concepts. 3. Apply the formula and concepts in solving physics problems related to motion. 4. Evaluate the results of the problem solving if it conforms reality. Let us define motion. One definition is, motion is the phenomenon in which an object changes its position with respect to time. Motion is also defined as the change in position of an object with respect to its surroundings in a given interval of time. There are general types of motion. We have rotary motion or circular motion, a special type of motion in which the object is on rotation around a fixed axis like a figure skater rotating on an ice rink. Another kind of motion is the oscillatory motion, sometimes called as periodic motion or reciprocating motions, otherwise known as simple harmonic motion, abbreviated as SHMs, a repeating motion in which an object continuously repeats in the same motion again and again like a swing. A repetitive and continuous up and down or back and forth motion like a needle in a sewing machine. Oscillatory motion would keep on moving forever when there is an absence of friction, but in our real world, the motion eventually stops and comes to an equilibrium. Motion can also be classified according to the number of directions involved. We have the linear motion, a one-dimensional motion on a straight line, like an athlete running on a straight track. Followed by the two-dimensional motion. Two-dimensional, 2D, motion means motion that takes place in two different directions, or coordinates, at the same time. One example of 2D motion is the projectile motion. We also have the three-dimensional motion, motion in space, which incorporates all the x, y, and z axis, is called three-dimensional motion. Just like the movement of electrons in the atom and the movement of the gyroscope. A good look on the classification of motion is shown below. We can start describing motion using the elements involved in motion. First, we try to differentiate distance from displacement. Distance is defined as the total distance covered, while displacement is the total directed distance covered or traveled from the initial to final position. Distance is a scalar quantity while displacement is a vector quantity. In this slide, we will calculate for the total distance traveled along the perimeter of the rectangular court. We see that point A is 10 meters away from point B is 20 meters away from point C. If you are going from point A to point C, by passing through point B, you have traveled a distance of 30 meters. You can get this by adding the lengths of the segments. But, if we are asked to find the displacement from point A to point C, we need to draw a straight line from point A to point C and the measure of this directed distance, and it is the displacement from point A to point C. We use the Pythagorean theorem to solve for the length of the directed distance or the displacement from point A to point C. We see that you can start from the same position and stop somewhere else, yet you will have a different value of distance and displacement. We realize that distance depends on the path traveled, but displacement only depends on the length of a straight path connecting the initial and final position of the object. Another element of motion is time, and it is defined as the duration of events or motion. It is measured in seconds. We can compare two runners in a racetrack. We can quantify our observation on who's faster using speed. Speed is the ratio between the distances covered per unit time. If you have traveled greater distance in a small fraction of time, that means you are fast. It has a formula given by S for speed. S is equal to distance divided by time, or S is equal to d over t. Velocity is another term related to motion. Velocity is a vector quantity that refers to the rate at which an object changes its position per unit time. Velocity, quantity that designates how fast and in what direction a point is moving. A point always moves in a direction that is tangent to its path. Velocity is the directional speed of an object in motion as an indication of its rate of change in position as observed from a particular frame of reference and as measured by a particular standard of time, e.g. 60 km per hour northbound. The symbol used in place of velocity is lowercase v. Velocity is equal to displacement over time. Or if the motion happened along the x-axis. We can say that there is a change in the coordinates along the x-axis and this change happened over a period of time. We say that velocity, v, is equal to delta x divided by delta t, or x sub 2 minus x sub 1 all over, t sub 2 minus t sub 1. For those who know their algebra, this formula is just like the slope of the line. During a trip, the velocity of the car changes. We may wish to know the average velocity during this trip. We may not know the values of intermediate velocities, but we can determine the initial and final velocity. We divide it by 2, and that is how we get the average velocity. From equation 3, we can determine the initial and final position of an object or a particle. We cross-multiply delta t to the right-hand side of the equation and we will see that delta x is equal to the average velocity times delta t, which is also equal to the quantity of final velocity plus initial velocity divided by 2 times the quantity of delta t. And since delta x is equal to x sub 2 minus x sub 1, we equate it to the quantity of final velocity plus initial velocity divided by 2 times the quantity of delta t. Finally, we add x sub 1 to the left-hand side and right-hand side of the equation, thereby giving x sub 2 is equal to x sub 1 plus the quantity of final velocity plus initial velocity divided by 2 times the quantity of delta t. This is our equation 4. Another concept related to motion that we experienced in our daily lives is acceleration. You might run faster if you ever see a snake somewhere. This change in your velocity is called acceleration. Acceleration, denoted by lowercase a, is a vector quantity and is equal to delta v all over delta t. This is also equal to final velocity minus initial velocity all over final time, initial time. This is our equation 5. From equation 5, we can try to find the final velocity after the object has undergone acceleration. We cross-multiply delta t to the left-hand side of the equation, giving us a times delta t is equal to final velocity minus initial velocity. We can solve for the final velocity and it is equal to v sub f is equal to v sub I plus a times t. This is our equation 6. We can use equation 6 to modify equation 3, which is the formula for average velocity. The formula for the final velocity from equation 6 is to be substituted to the final velocity in equation 3. We have average velocity is equal to v sub I plus v sub I plus a times t all over 2. We can simplify this as 2v sub I plus a times t all over 2. We find that the average velocity is equal to v sub I plus the quantity of a times t over 2. Equation 7 can be equated to equation 2 to find the final position of the object after it experienced acceleration. We have delta x over delta t is equal to v sub I plus the quantity of a times delta t over 2. We multiply delta t to both sides of the equation and we get delta x is equal to v sub I times delta t plus the quantity of a times delta t squared all over 2. We can solve for x sub 2 and we find that x sub 2 is equal to x sub 1 plus v sub I times delta t plus the quantity of a times delta t squared all over 2. This is our equation 8.